It's so cold. This cartoon ape in a jungle enjoys making games as well as playing games. Facts. An example of which is small towers down below. Facts. At some point we're going to get back to shuffleboards. Actually, I'm thinking more and more about that because we're so close to being done with our character design work on Shuffle Wars, the battle card game that we stopped working on like a good 4 months ago. We stopped so we could make small towers. That's done. We've been doing variety games and a series called Design Chat, along with a series called Design Workshop. So in Design Workshop, we make things. Design Chat helps us focus on what we're going to make. Because at first, Design Workshop just had us playing around in a game engine like Unity. And it didn't look that busy when we started. We were just doing small things. And that's the point. Anyone can do this by taking small steps. And so we started with small steps in Design Workshop. Design Chat said, hold my coffee. Let's talk about what design is, what it isn't, what you need to make a game. And then we began to use those minimum requirements to make a game. And so we kind of have one. I'm very much struggling. It is super, super cold. Apes aren't used to the cold, I'll just tell you. I mean, our cousin the Yeti is, but not us. Anyway. Jungles aren't supposed to be cold. I digress. The game is relatively straightforward. You are a character that can move around on a 2D plane. The 2D plane is your game world, and part of that 2D plane is a square you're trying to get into to win. The only problem is this win square will shrink, so you have to get there in time or you lose. Minimum requirements like this make a game, we're good, yeah? We say, well, that's fine for, like, the basics. Now we're going to have things that work against the player. Sure, let's add a wall. Okay, they have to get around the wall. Okay, let's put a bunch of walls together. Graduate to a maze. And we did that. Most recently, we've made level 4, which looks like a maze. We did it because we have pieces, like an L shape, a T shape, a dead end, a straight piece. And with these together, we literally just snapped things together, and it was actually very fun, easy. So even the most complicated maze that we've made so far, we made it simpler by thinking ahead and saying, you know, we need these pieces to make it easier. Well, now we're thinking about a new piece, a door. So we've made another test scene. I want you to notice how many test scenes we have. A lot of test scenes, prototype scenes, test scenes. Prototype means test. We have just as many regular or working scenes as we do test scenes. Let's look at a wall prototype for a second. This is where we came up with a library of shapes that we would need. We developed them here, and now we use them here, you know. Well, let's talk about this because the door prototype has graduated a little bit. Last time we were here, we said, well, let's make it look like a door, and there was enough here to kind of look like a door, and Design Chat got hold of it and said, hold my coffee. Because we were thinking about another issue in Design Chat. This is what we made, only one door, but we made one door, and it looks like this. So our work today is going to make this door, work. Last time we made it look like a door, now we'll make it act like a door. But Design Chat is thinking ahead and saying, what happens when we have an activating thing on the door like a button? Excuse me, I'm really struggling. It is very, very cold. When we have a button, how do we visually tell the player, like the moment they start the game, how do they visually understand the relationship between a button and a door, right? We're going to probably have more than a few of this going on, especially if we have buttons activate more than just doors, if we have more than one door, if the activation and the door are nowhere near each other. So we're thinking ahead to find the problems, not to be like, oh no, more problems. No. To say, okay, these are the things we should focus on. To ignore the problem until we get there is, well, less ideal. In other words, we're spending the time to think ahead now, which sounds like a lot of time we're spending, until you realize if we had gone down the road of putting things together and then we ran into the problem, we would have to undo that work, redo that work, and still do the work we're doing now, which is figuring out the problem. So in other words, we're saving time by thinking of it now. So no, we're not spending time, we're saving time. The goal was this. Excuse me. The goal is this. The player immediately sees the level and it says level 7. Ready, set, go. That's a very short amount of time, and visually we would like our player to scan the level, which is a screen, and understand what's going on. If we just show them buttons, we run the problem that we're talking about. There's buttons, there's doors, what do we do? Design Chat said, well, let's think about that. That's actually going to be a longer term think because we didn't really come up with a solution. This is one idea. Let's draw lines. And then we thought ahead about what is the drawing the line process going to look like when it gets complicated. Okay, so Design Chat is on the case. We can trust they're going to figure this out. This might be part of the solution. It might also be color coding. We'll look at that. But we don't know yet. When they figure it out, we'll make it. Okay? Our job is going to be straightforward because we already know what we're going to do today. But there are two parts to this door because it is a door, but it also is going to be activated. If, we talked about this last time, if the door is just, you walk up to the door and it opens, then what's the difference between a door and just a passage, right? We just pause here, right? There's no difference. In other words, for it to mean something to the player, see, it is about the player. For it to mean something for the player, this has to be a barrier that can be opened, but not just by walking up to it, because that's just a pause. A passage in which you must pause is not a door, right? This is like a gate where you need to open it. So open this, open that, and then you can go through. That's the idea. Boy, I sure hope my mute button is working. Wow. Excuse me. Yes, I've had a whole cup of coffee, actually. So, there are two parts to this, and today we're going to focus on one, the door. It doesn't move right now, but we know that this is going to slide up, this is going to slide down, this is going to be part of one piece that we already composed, and boom. Could it have an extra thing later with like these lines? Yeah, because that might be part of what Design Chat says we're going to need to tell the player visually what's going on. But for now, we have a door piece, and we're going to make it work. Design Chat said, yeah, that sounds really good. It's going to be something like this because we like the idea of a door and a switch or button makes more sense because we already have a button. Very soon, we're going to be tasked with making the button work as well. And yes, right. But that's part two. Part one is let's just get the door working, right? So, yes. We are looking at what Design Chat did, and they said, yes, we're going to do this sliding door thing. One goes up, one goes down, and it's going to animate. When it opens, it animates. When it closes, it animates, okay? And we've already confirmed that when it's closed, it doesn't allow the player to go. When it's open, it's good. So door, that's what we're going to work on today. Okay. This is Design Chat thinking ahead about what it's gonna look like and what we're gonna need. In fact, they're thinking about different types of buttons. So when we get to the buttons, we're going to be thinking about it. When it's very, very clear visually, just to let you know, it turns out to be a lot of work that we're thinking of ahead to try and figure out what's the most efficient way we can just make this stuff. Because level design is going to be a lot. But door, and we may have other things that buttons could activate. We want to pay attention to two things. Design Chat says anything that can be activated, and I don't know what to call these actually. Dynamic props, because it can be changed. Don't know how to spell dynamic. Dynamics? I don't know what we're calling them. They can be activated and reset. Okay? Because if it's not dynamic, it doesn't change. But if it does, like a door or I don't know what else, it can be activated and reset. In the case of a door, reset means close again. Yeah? But what we're thinking in Design Chat is that might even apply to buttons, where the button could be activated and reset, like the player gets on it and it's activated, right? But depending on the type of button, it might be reset. So we'll talk about buttons when we get there. For now, door. Both activation and reset, meaning it receives a signal to activate or a signal to reset. And in the case of the door, activation means doors open. Reset means doors close. And I think that's all we need. We do want it to animate, though. So let's look at that. I don't know if we're going to call it dynamics. I'm not sure. I don't mean to pause like that. I just have to. Okay. I'm going to, for the moment, ignore these extra bits. And we're just going to focus on the door. And right now we have two. I'll ignore the second door. And we will just get this one door to work. Okay. So I will get rid of my avatar. Okay. If we know that there are static pieces on this and dynamic pieces, right? These two door pieces are dynamic, and there's going to be a script on this thing, right? This kind of makes sense. Let's put a script on this prefab for the door so that it can receive a signal and then do things to the door pieces. Makes sense, right? Let's make a new script. Under props, I guess. Scripts, props, sounds good. Script. Let's call it door, right? Door piece. It is a dynamic, right? I guess we're now calling them dynamics. Okay, here's some code that happened a while ago. Thank you, Visual Studio. No, I'm looking at this one. There you go. Okay. I can't help it. I'm going to fix this first, and then we'll move on. So door dynamic, what is this script going to do? Well, it is going to move door dynamic pieces when activated or reset. Sounds pretty good. And with that, cool. Oh, I'm gonna get really cold. My arm has to be out. It's really cold. It's really cold. Okay, that's a me problem. That's not a you problem. So, okay. This door dynamic is a script. It is going to live on door pieces in general. And so, like any modification we did to the door, we added these door squares, rectangles. And then we just said, yeah. Change our prefab, override it, and apply that to the original door piece. So now the original door pieces have all the corners plus these new door pieces. Yeah. Well, we can add the script here. That's true. But I also just want to point out we can do this. I can just add it to our... I was going to say add it to this one, but it's got... That's okay. I was going to say it's got settings here that I don't want to apply to the original, which is a case to say either I'm going to reset it here when I apply it, or maybe we actually do just double click on the prefab and add it here. That's fine. I think we've done it both ways, which is sort of what I wanted to do, is just show it off. So door pieces now have the script on them, including our copy here, does it? And so does this one. Yeah. Cool. Okay, we actually don't even need to touch this anymore because it's all on the prefab, and now it's all on the script. What we do want to do, though, is say the script should know about these two pieces, yeah? The script needs to know about these doors in order to move them. It needs to know about these numbers. I mean, I've been playing with these numbers. And I said, if I move this top one up, like this, that looks good. Bottom one down, like this, looks good. So those numbers are what we need to remember. We also kind of need to remember that we like that these are in front of the other square. In other words, this z value should be that. Okay. Is there anything else? I don't think so. As long as we can reset this and set this, right? Activate it, reset, that's all. In fact, activate and reset is also something we want this script to know about and remember. We want it to remember or have a reference to. Okay, we're making a script and the things we ask are, hey, what does what should my script remember and what should my script do? It should remember these two squares and those numbers. It should do the moving. Right? It should also remember whether we are in a state of activation or in a state of reset. So when we receive a signal and it's like the signal to reset, but we already reset, we're not doing anything. But if we're in activation, then we reset. In other words, there's two states. There's closed, there's open. We want it to remember those states. So let's add those things it should remember and make it look like it should look here. In other words, if we add variables, it'll look like settings. And we've done this before, like our player character had settings for moving. And so let's make the settings look proper first, okay? So our door needs to have those settings. The door pieces, I think, might be things that we can find. The script can automatically configure. But especially whether it's in the state of activation or reset. I say that instead of open and close, simply because we're going to have other dynamics, okay? Okay. Let's open the script and do that. Why does it say restore up? Where does this come from? I don't know where that pop-up says restore up. I don't know where that's coming from. I guess we could investigate. Is this Visual Studio? It is. It's Visual Studio. Okay. Hey, Visual Studio. You got a little bug. It's not a big one, but your pop-up doesn't go away. It just stays there. It looked vaguely like a pop-up from Visual Studio. That's how my guess worked. Some settings on this door. We want it to know about two states. Have we talked about enums? I think we have. We didn't use it, but we were talking about it in terms of our character, if I remember correctly. Character. We have, these states, right? Move states. Well, we're thinking about different states, but for our door now. And in fact, we never used these, but I'm glad we talked about them because I'm going to do it again. Animate character has something called an enum, which just simply defined a list. This list of names are the different states that we were going to use, we ended up not using. Let's do this, but for the door, and say activate or reset. Boy, this begins to bring up the case for making a root class of all dynamics and then have a subclass for the door, but I'm just going to do a door, thank you very much. And then check it out. Once we did that, it was called movement state, even though it was just a list. And this can be a variable of this type now because we just made it. And so this can remember that state. Let's do the same thing. We're going to make a public enum. This is enumerator. It's not even telling you what it is. It's an enumerator. It's a numbered list. I'll prove it's numbered. Let's call it door state, because in the future we're probably going to have something called dynamic state, I think. But reset should probably come first, I think, because this is the default. This is what it will be in the beginning. And closed sounds just about right. Activated. I think these are states, so they have to describe what state it is in now. It's in state of reset or state of activation. Activated. It is reset or it is activated. Okay, fine. Let's do it that way. But these are numbered because if I hover over this, it says reset equals 0. Activated equals 1. It's a numbered list, so it's enum. Okay, but now that we've done that, we have a variable we can use that we made all by our own selves. It is called door state. And yeah, it's called just state, that's fine. This means, because it's all public, it is available in our inspector. And so when I save and go back into Unity, and I look at our door, it has a script, and it now has this pull-down menu. This is reset and activated, 0 and 1. It is a state. It's the state of the door. By default, it is reset. This looks great. Let's move on. So it has the ability to remember, and the script needs to know this. You'd think, well, wait, it's the door. Doesn't it know it's closed? No, it actually does not. It has no idea what it should be doing with the door pieces unless it knows this, and we need to make sure it knows that. That's why we're doing it. But it does. Now it knows. It's all good. So, we need to know about the door pieces. There are two game objects. There is door A and there is door B. These game objects are children game objects. We could use game object. We could also use transform, which is something we're going to access anyway. I say that because, literally all we care about these doors is changing these numbers. But, so here's the script on this game object, and we're saying there is a child game object. Actually, let's just test this for a second. Should we do transform? Because if that's easier, why not do that, right? Transform is the name of this component, and if what we remember is not a game object, and then we need to find the transform, instead, if what we remember is the transform, then we're right there. Actually, now that I say it, it sounds a lot simpler. It would be like this. We already defined this, and sort of it exists. I can test with it right now. So I'm going to say, hey, door A. We're going to get to your transform, and we're going to, mess with your position. Actually, local position. The difference being, this is the position of the child. Those numbers in the transform are relative to the parent, and this is the child's position relative to the parent. That's the difference. Otherwise, position means the world position, which could change because we're going to move this door around. We're going to move the door. We're actually going to rotate the door, so local position is actually necessary. Okay, so this is how we would access that. But we're always going to go to transform. Yeah, it probably doesn't make any sense to do that. If we find transform first, then it's easier. So this was game object with a capital G, because that's the class, right? And we could say, hey, excuse me, I need to demonstrate this, but Visual Studio is fighting me because it doesn't like this code that is not done yet. If I say game object with a lowercase g, I'm talking about the game object this script is on. That is different than the capital G. That is the class. Our game object is a capital G class game object, but it is specifically this one copy of it that this script is on. And likewise, when we say game object.transform, we're talking about the transform on this game object, right? But if I say capital T, like I'm going to do right here, I'm talking about the class, and I'm saying this is a variable type. I'm going to have door A, but it is the transform of a game object. Okay. Transform is where all these positions are, so I need it. Transforms live on game objects, so it's kind of just a choice. So we figured out a simpler choice. So it's looking for a transform for door A and door B. So get this, we could just do this, right? And that's fine. It's fine, right? There's nothing wrong with this. Now, literally all of the game objects that are doors have this configured already, including the one we turned off. Like, this is already there. It knows to look at its children door transforms. It knows. Oh, hi, this one? Yeah, there you go. It knows. But as we've been doing before, I'm going to do again. Let's have our script auto-configure this by finding what it needs. Because if I throw down, I don't know, a door and decide to remove one of the doors, like, I don't know why I would ever want to do that, but weird things happen. If it's just missing because I made a mistake. Now, this is missing. If my script assumes it's there, this will cause all kinds of errors. So I would rather have my script auto-configure this and complain very loudly if it has a problem and cannot find what it needs. In other words, I'm not going to do it this way, but I will look to see this is filled in at start when I hit play. I'll do that. Should we auto-configure? Let's do it. I would be looking for, let's see, a child object and getting its transform. Yeah, let's look for a child and let's see if we can find it by name, because door A and door B will be the name. It's also the name of our variable. So door A, for example, equals something that we can find. We're going to say, hey, this game object, that is this, the door piece, the root object, go look for some children. The way you can find children and parents is through the transform. This transform handles the position, rotation, scale. It also secretly holds parent information, including what parent are we attached to, but also what children might be on this game object. In this case, I want to find a child. Is that there? It's find child. Can we do this by name? Perfect. Oh, it's depreciated. Bro. Don't tell me that. Is this... Oh, this is the same thing. Okay, so this one is a function. It does actually return a transform. This is really straightforward, actually. And it is a function available on any transform class, so this is one of them. And it does find the child by name and return a transform. That's great. But it says depreciated. What does that mean? It means that it used to be there, and I guess we could technically use it, because it's actually right here. However, the fact that it is telling us depreciated means that very soon this won't be here at all, and if we code this now, and they update Unity or something, maybe it's not there, and then our script is broken, our game is broken. So what it's trying to say is, in fact, often the error messages will tell you, please use this instead, and it will point to whatever it is it should be using instead. This apparently is what we're going to use because this is not depreciated. Otherwise, it's the same. Return a transform as output when you call this function called find. We're going to call this function called find and give it a name. In this case, it's going to be called door A. So hey, game object, that's this game object. Go find a child by this name and give us its transform. Well, perfect, because we actually want a transform here. So that was a good choice. That was a good choice. And if it was wrong, we would have just revised our code and made it more efficient. That's fine. But let's see if this works. Go find these children by this name and assign those variables. Do it automatically. Oh, I'm in the prefab. Okay, are we running? We are. We're blinking. I can tell we're running because the character blinks. That's hilarious. Here's the door piece, and there are the transforms. So these are auto-configured. Oh, this one is not. Check it out. It's off. It is not. This piece is deactivated, so it is not here. And so it hasn't been filled in because this script hasn't run. But check it out. When I click this button, I'm going to activate the whole game object, including start running this script. And boom, it knows where these are. So excellent. This is by design because if these weren't here, we would want it to say so. We would want it to be very loud and say, hold on, there's a big problem and we need to find a way to make sure these doors have the door pieces they need. I mean, really. How do we do that? We've talked briefly about validating. Can we validate that this actually exists after we get it? Yeah. I can say if door A equals null. Now we just did that recently, or at least I think Design Chat actually did it when they did this game manager thing. They said, don't worry, we'll see if obstacles exist, and if it does not, we won't work on it. Actually, they went find too. This is game object find, which goes finds a game object by name. We're finding a child object by name using transform. They said, don't worry, we will validate before we work on it, because we're going to say if obstacles does not equal null, then we know it's there and we can work on it. If it is null, it'll skip this. That's validating. We're going to do the same thing. If this equals null, then we're going to say, whoa, and we're going to bark very loudly. I'm saying if it equals null or, this symbol means or, door B equals null. This entire condition could be triggered to true if either of these is true, because this is or. And this one says if that's empty, or if this one is empty. Either of those, if either of those is true, then this whole thing is true. What we'd like to say is, hey, we could say print, right? And we could say, there is something wrong, right? There is something wrong. Okay, but this is not descriptive. We would want a better way to highlight there's something wrong and what it is. I'm going to have to move it along to get going, but the point is, this is a shortcut for something called debug log. It's just a simple print message to the console, debug log some text to the console. But it's debug. It's a class all itself, specifically designed for feedback while we develop. And there is something else called log warning. And this makes the same kind of print to the console, but with a little warning sign, and it's yellow, and it looks like a warning. This literally makes an error message, and I would like to do that. If we don't have door A and door B, this door doesn't work. Something is terribly wrong. So it's not just a little bit wrong. We would say, there are door pieces missing. And this is still not descriptive enough. I would teach that an error message needs to have 3 components. Which piece went wrong, and I would even identify this game object's name. What happened? In this case, we are saying there are door pieces missing. And what to do about it. How about that? We'll do that. We'll say fix door. That's good enough. This is, I'm just pointing out validation, and I don't want to go down the rabbit hole. I just want this to be there. I want to guarantee it's there. If start finds it, this will be fine. If start does not find either of these, this will bark loudly. And I guess we could test that by, running it and seeing these are there and seeing nothing in the console. But if I actually delete one of the doors and run again, right? When would we ever delete a door? Well, we wouldn't do it on purpose, but check it. This actually looks like an error message. There are door pieces missing, fix door, because it can't find it. And this is very good to know. It's not bad to get an error. The only time it's bad to get an error is when you don't know what to do about it. But we get to say exactly what to do about it. In this case, fix the door. So I did. Okay. Yay. We know if we are reset or activated. We know about the door pieces we need to move. These door pieces would move like that. Okay. So let's... I think I need to save and remember. I need to remember that position. Look at this position very carefully. I like this door here at 0 in X. 0.381. Trust me, it's the golden ratio. It's great. And Z just a little ahead, or negative 0.01. So it's on top of this piece, yeah? I like that. And the other position is just moving Y from this to 1. That's all. So I like knowing what those are. Let's do this. Let's say the script will remember those positions so it can move the doors it needs to. The numbers will be up here in this script on the parent object. Knows reset, activate. Oh, time. How much time is it going to take to open the doors? That's a great question. The variable type that's good for time is a float, in other words, a decimal point number. Change time. This is like the maximum amount of time it takes to change. And let's go ahead and just set a value. I don't know, 0.5? Like half a second, basically, in seconds. Time is measured in seconds. Game time is measured. But we're also going to track time, I think. Like this number stays the same. We can set this to whatever we want, so we can move it slower or faster. This is going to be another float variable, but it is a timer. And it'll start at that value and probably count down. That's probably what we're going to do. Yeah, because we were going to move it over time, but I wanted to remember those positions. Those are vector 3 positions. They have an X, Y, and Z. This is what? Reset position? Yeah. This is activated position? I think so. I want to remember these two positions so I can just say move toward them. Actually, we haven't tried to move yet. I mean, we've moved the character. And we're probably just going to move the same way. But, yeah, we haven't talked about doors. Like, what happens if the character's in the way when it tries to close? Do we squish the character? I don't think so. Not in this game. And not in most games. Players don't expect that. Would we then not close? I think so. I think we'd have to do something similar to what the player character tests a cube just ahead of where it's about to go, and if it hits anything solid, it has to stop. That's the collision detection we did for this game. We should do a little bit of that for these doors, I think. Or the door itself detects the square in the middle, probably. And if there is anything solid here at all, then it won't close. Like the character could hold the door open by being here, but as soon as they move away, the door knows to close. Something like that. I mean, that's kind of like how the door at the grocery store works, right? All right. I'm not overthinking it. You're overthinking it. So let's go ahead and Save our script so we see change time appear. And are we done? We haven't talked about moving yet, but I think we can make a separate script for moving the doors. So what is the reset position and the activated position? Well, we can set those actually, can't we? I think so. By default, these could be just 0. That's fine. 0, 0, 0 is fine, and we can modify them from there. This is one way to do it. There's more than one way to do it. But I'm saying, like, this is now this is filled in with something, right? It just happens to be zeros, but I can change that because it exists, because there is some data in there. And I can say, yeah, here's another way. Sorry, I want to move this along. I can say new. The new keyword basically is the safest way to always be able to do this. I actually don't need to do this now if I'm doing it this way. I was going to do it a different way, but I'm going to try and move along now. Hello. Please don't do that. Visual Studio. So, new, this keyword before the class, says I'm going to access a special function on this class called a constructor. You don't need to know this except to say that new is the safest, easiest way to always add some data to an empty variable. This is totally empty, and now I'm going to fill it with something, and this is always safe. In this case, these constructors can have numbers in them. I can do x, y, z, including just this. I'll say it's closed at first, I suppose. What was it, negative 0.01? Yeah, that's the reset position. That's the default position. That's this set of numbers right here. Door B. You are different, aren't you? Aren't these already in the reset position? They are. Can't I just ask the script to go look at these numbers and fill in what the reset position is by looking at those numbers? Yes. Yes, I can. Hey, script, go look at what the door A position is. Yeah, I'm going to have to change it for door B, aren't I? Wow. Local position, please. Local position, like I said, it's the child's numbers. The difference is that those numbers won't change no matter what I do with the parent. Okay, I can have several doors all over the place, rotated, moved, and these numbers will always be the same because relative to the parent, the door A moves only in two positions. So, the activated position is actually simple as well because I'll take door A local position and then I'm going to say the activated position in Y is 1 because that was the only difference. This door went to 1 and that's it. So we're remembering door A as the master, I guess, for how doors should act. Door B is just different because of this Y value. It's in negative. That's not that hard, I guess. We can fix that. We can make that easy. But we needed activate and reset positions. If we do decide, you know what, 0.01 is not enough, or it's too much, well, we can change this. In fact, we could change the scale. Anyway, we can change these, and this script will still work. It will remember the correct numbers, the updated numbers. Okay. I will move along. Oh my goodness. Yappage. Yapping and yapping and yapping. But what we've got is the remembering, including where the doors should go and a reference to the doors and even how much time they should spend, right? The state is like the current state. You know, let's call it current state, actually. And we said we want these dynamics to receive a signal that is, please do activate or please do reset. Receiving a signal meaning a function that other scripts can call, which we've done before. We've done this before. This was a public function. Where did we do this? Here we go. A public function is a signal we get from another script. So we know what to do when we get that signal and the other script has access to this function. It can just call it when the signal needs to happen. We're going to do the same thing. Because our button or whatever is going to say, yo, activate. So we need a public function. It does not need to return any value at all, so we'll just say void for output. But activate dynamic? I guess we could say door. Let's speak plainly. We'll fix it later if it needs to be more generalized, but activate door is sort of the thing, and here's the key. It's either going to be true or false, because we are true, activating the door, or we are false, resetting the door. And that means that we're going to include a true-false variable, or a Boolean variable, activate, I guess. So if it's true that we should activate, this will be true. If we should reset, it's going to be false. And that is going to be compared against the current state. Because we should also have a state that we're trying to get to. There's going to be time in between when we are starting to get the signal. We could be reset and we say, okay, now activate. And so at that moment, we have a target state to go to and a current state we are in. I think that's true. We could also say, you know what, just look at the doors. And if the doors aren't in the reset position, then get to it if you're resetting. If you're not in the activated position, then get to the activated position. I guess we could do it that way. That's easy. Current state. So if activate, right, then we are saying please do activate. But if that is true, we do want to activate and we are already activated, then we should ignore this. Like I want to say right here, if we are activated and we're getting a signal to activate, we should ignore it. If we are reset and we're getting a signal to reset, we should ignore it. So I kind of want to ignore if already in state is what I'm trying to do. And then we'll do stuff, right? We'll do stuff in a second, but I need to ignore this first because then I can guarantee that we're supposed to do something. Right, that's true. That means if activate, where this variable that we're getting is true, right? Because that if I just say activate, it means if this is true. And the current state we're already in is activate. And so I'm asking the question with two equal sign. Is the current state equal to the door state dot activated? If that is true, I need to ignore this. The way to ignore it would be to say return, because we've called this function And it will return some value if it is supposed to return a value. It will return by default at the very end, but we're saying return right now with this keyword. This skips the rest of the do stuff. Well, hold the phone, because I would also like to ignore if, and I'm sorry to add all this complicated condition, but now I'm under the gun and trying to finish and we're already over or something. I mean, I could do this. I could say, well, if we are not activate, like if the signal is to reset. So I could also say it this way. That exclamation means not, but I could also say equals false, same thing, right? And current state equals reset. Yeah, Visual Studio knows what's up. So then I could do it this way, right? And this is fine. But I would note immediately the way I'm doing the same thing twice. Can't I just combine these two conditions? And the answer is yes. I'm saying and right here, right? And I said or up here, right? Well, I can combine all this and use some parentheses to put, I'll just do it and you'll get it. There's going to be a very large condition that includes this and that, because I'm going to say it's either these two are together or these two are together. And if either of those is happening, right, we are in the activated state already, or we're in the reset state already, then return. Okay, so we added parentheses around this, so it's evaluated first. We added parentheses around this, so it's evaluated first. And so now this or has just two things to look at, and if either of those is true, right? Each of these is evaluated and it has an and, so if this is true and that is true, then this is true. Okay, I'm going to have to move on. This signal is ready to be thrown at, or, called from a button. And we just say whether we're going to activate or deactivate, and it's ready to ignore it if we're already in it. Great, so now we need to do stuff, yeah. Set doors to move to target positions. I think so. And I think door A should really be driving the whole thing, because that's going to be the comparison. Like, there isn't anything door B is going to do that door A isn't already doing. It's just the Y value is opposite, that's all. So let's have door A drive the whole thing. Okay. So I think we need a target position, because I just said that. I didn't realize that, but I think we needed one. Let's make a private vector 3 that can either be set to reset or activated, but it is the target position, whatever that is, yeah? I suppose if we're already, if we start and reset, then target position does equal the reset position. I guess that's true. In the beginning, target position should equal this in the beginning because doors are closed. Okay. Let's, gosh, I hate to cut it out halfway through. We're going to have to go long. I'm sorry. Doing things in 1 hour blocks sometimes works out great and sometimes not. But this shouldn't be too hard. We already say where the position is to reset, where it is to activate, and we're now going to remember where should we go now? What is the place we should go to now? Because we've gotten a signal, and so we're going to say, well, cool, target position should equal something. What are you doing, Visual Studio? This unary operator is not something we've covered at all. We're not going to do that, thank you. But it is going to equal something. Okay. Well, let's just keep it simple. If activate, then we've gotten the signal to activate. And so therefore, the target position should equal the activate position. Am I Am I missing something? No, that's it. And else, right? There's only two things we can do. So if not this, if activate is false, then it will skip this one and do this one. And I'm sorry if I did not put the curly brackets in. It is not necessary if we only have one line of code, but it's no problem if I add it. That's okay. So either we're activating and the target position should be the activated position, or the target position should equal the reset position. Okay. Now, I like that we ignored this and we validated that we should do something before we did it, right? This is input, and we just want to make sure that we should do something by validating before we do it. And this does, in fact, ignore if we don't need to do anything. It's good. It's good. It's good. So we can receive this, and the target position will now say something in relation to what door A should be doing. Like, where is door A in relation to the target position? If they aren't the same, then we should be moving, and we should be moving every single frame, right? Okay. In fact, we should be moving according to this time, right? Because we want this change time to be a thing, right? So let's set a timer at the time we change the position. What do we set it to? Well, we have this property called change time. So let's set a timer. Timer equals, hello, change time. There we go. Meaning, yeah, we're going to ignore this if we don't need to do anything. But if we are, then change time is, the timer's been set. And so, while we actually do want to review the idea of check collision in doorway, yes, that's actually a thing. We do want to do that, but we'll do it later. Right now, we just want to move the doors. We want to do it on update because every single frame it can be moved. It's a good time to do animation. I know this is called every frame. Thank you. I know this is called at start. Thank you. Oh no, you deleted it doesn't matter. It's just noise, actually. I'd rather look at the comments that I have rather than the garbage comments that I already know. So, let's save. Let's go into the scene, and we can see change time is here. We hit play, and our script is auto-configuring. It's kind of ready to go. We could kind of say activated. This won't reset the timer, actually. Can we test? Yeah, what I'm playing around with is how am I going to test this when it is working, and I can't actually. Because I'm expecting to set the timer when the signal is given. Well, have a signal. Let's have a test routine. What I mean is, I'm going to add a temporary variable. It will only stay here for a little bit because we're only going to test, and it is going to be a public variable. It is going to be test. And I will remove this. I will delete me. I will delete that. Yes. But first thing I can do is say, hey, if test is true, right? I can say that, or I can just say test because it is true or false. That does work. Then please set test to be false. This pattern I use all the time. What it means is there's a little checkbox that while the engine's running, I can just click. And it's like a button making something happen. Here's the something. Please activate door. Activate door. I'm going to call this same function. And I will say that activate is true if our current state has been set to door state activated. In other words, if we changed our current state manually in the inspector to activated, Then activate door true sets this all in motion, including the timer, which I want to test. I'm also going to test this. And this will turn off. And yeah, we can test that. If the current state is set to reset, then this is false. And so activated is false. And that likewise works. Let's test that theory. Oh, I can't actually. But this is how it would work. I have played, and now I can say I want it to be activated and go. And I just clicked, but it turned it off immediately in the same frame. So I can set to reset, click, set it to activate, click. So it's a way that I can test quickly. I'm going to remove that in a moment. Okay. Can we move these doors finally? Sheesh. Let's run the timer down and use the timer as a means to figure out where the door should be. Yes? There is a change time. This is the maximum amount of time. Change, right? And this is the timer. This is the current time left, right? Remaining, yeah? That's what these mean. So when I set the timer to that maximum, now I'm going to run the timer down. Run timer down if timer is set to something, right? Because if timer is more than 0, then we want to run the timer down. That's what that means. And if it is 0, then we don't care. Or if it's less than 0, we don't care. But we are going to set the timer to something when we need to, and then every frame we can say, cool, now reduce that timer, reduce it by an amount that is equal to the amount of time it took to render the last frame, because update happens every frame. This is super accurate. It's a very small, tiny little number. And now our timer is running down very accurately. At this moment, it may have crossed down below 0. We don't know, but we can ask the question, hey, is timer below 0? Because then that means the timer is up. And by the way, please do set timer to 0. So this pattern I use all the time, and I'm able to use timer now. And in fact, I'm able to use timer in relation to change time. This is the maximum, this is the current. That's now a percentage I could totally use. And we're going to use it right now, actually. If timer is up, I guess we could set door positions appropriately. In fact, I just said the words set door positions, and it sounded like a function. I'm going to make a function called set door positions, because I just want to give it a vector 3 door A position, and I want it to know that door A local position, should equal that door A position. Whatever I say it is. And I want to potentially, can I change this input value? Let's actually just say door position, because this is going to get confusing. Can I actually change the y value of this? Can I say, make it, like flip it to be negative by saying times -1? I can. Okay, good. So then door B has a y value that is flipped, and I just say go. I think that's okay. We should test this, but I need to move on, so I'm going to test it in a dangerous way by moving another step ahead. It's okay. This, I know, actually, let's go ahead and test it. Let's just test. Hey, on start, can we please set door positions to 1? This should be open. On start, open the door. Should we test this theory? Here we go. Oh, what's this error about? Oh, cannot convert from float to vector 3. Well, yes, of course, because I actually just need a float. I don't need a whole vector 3. I mean, I could, but I don't need one. Oh, right. No, I do need one. Okay. Because these are vector 3s I'm going to set. True. Okay. Yes. Can you just set it to the activated position, please? That's fine. Cool. So in other words, open the door. That's the same thing. That's true. It was complaining that I was trying to assign 3 numbers, but I was only giving it 1, and it says, you're missing some numbers. Okay, so I'm going to hit play, and I'm going to see if this door opens. Hey, it totally opened. Check. Nice. Which means that function works. In fact, it works on both the doors, which means we only need to call one thing. Good. Cool. I just said set door positions, and I think I told myself that's exactly what it needs to be. So, if we are trying to get to opened, I do apologize for going long. I do worry about that. I am trying. I'm going to test after setting it to be setting the current state to be reset or activate. I'll hit test, and it should check to see if it's already in that state or not. And if it is, oh, this will always be ignored. What am I doing? This will always be ignored. Okay, during this test, I will take away our thing, and I will remove that after our test. Because I just realized this would always be true. This would, yeah, never mind. This is still necessary. I'm deactivating it because we actually need to test while those conditions would normally ignore it. Okay. So, the timer's running, and then the timer's up. And when the timer's up, we want to set the door positions to whatever, either reset or activated, 100%. They need to stay there. The timer's up, meaning there's no more moving of the doors. They just need to be locked in that position, either the reset position or the activated position, depending on what the current state is. Lock doors in place, fine, whatever. If the current state is reset, okay, then that means set door positions to reset position. Right? Easy. Else, right, because there's only 2. And if it wasn't 2, we would change this, and we will come back and change it if we need to. But otherwise, activated position, yeah, that's right. This does run the timer down. This does set positions. We can actually test this, I think. It's not going to animate per frame, but it will, at the end of the timer, half a second, open the door, I think, if we do activate and test. Oh, it opened. And we can say reset and test. Boom. Cool. So it is doing a timer, but we aren't seeing the doors move. Can we make the doors move? Yes. Because I will go long. Here we go. The cool thing is positions can move. The cool thing is this activate door signal can work, and I will uncomment those, reactivate that code. And the cool thing is this timer runs. So let's use the timer when it is not the case that the timer's up, right? In other words, if the timer's up, we do these things, and it looks pretty good. But what about while the timer's running? Well, I want the doors to move. So if timer, the value is less than 0, and then timer's up, else we're moving, right? Move doors, which is really going to be that really minor teleporting that we do. Just reset the door positions, right? We have these positions reset and activated, but we don't have like the in-between, which is what we're going to need. In fact, there is an in-between that we need. Let's actually call a vector3 variable that we make right here in between, right? Position. And we could currently set it to 1, like either one, like the reset position, right? And I hate to bring up a brand new function name, but I'm going to do it. We are going to ask that we take, we're going to ask the relationship between the total change time and timer. Now, if this were like 1, right, then we would set our timer to 1, and it would run down. And that timer would represent like a percentage, actually. 1 being 100%, 0.5 being 0.5, 50%, etc. And that's cool. Well, the same thing is that even if this is not 1, what we would be doing is saying timer divided by change time is a percentage, no matter what change time is. It's a percentage of the total time left, the total time remaining. It would start at change time, which means 100%, and it would run down until it was 0%. So we can make a percent very, very easily. It is a float value. And timer percent, fine. That sounds good to me. And like I said, we just need to take the timer divided by change time. It's the maximum time on the denominator side, the time remaining on the numerator side. Sure. This is going to be a value between 1 and 0 for sure, which is great because we're going to multiply times this and get good things. I know we are. It's effectively progress, although it is backwards. It's okay. Excuse me. This in-between position is not correct yet, right? What we want to do is find what the in-between position would be. And let's actually I'm just going to organize this a little bit better, put it here. This timer percent is really helpful to say what percent of the time is remaining, yeah? This can be set to something between 2 positions, reset position and activated position, based on a progress or a percent. We can definitely do that. There is a function for this. In fact, I'm going to try this now and see if this works. The function is called something funny, and it stands for linear interpolation, meaning go between 2 points smoothly. And we are doing in between positions. So linear interpolation is a long word, and this got shortened to a funny word, lerp. It's a funny word. And there is such a thing as a vector3 lerp. What it means is we can just give it 2 positions, reset position, activated position, and then tell it the progress between the 2 points. That progress number may need to be adjusted, but we know the two positions, reset position and the activated position. That's actually really simple. So I'm going to suggest we use this because it is going to say, find the point between these two based on whatever this percentage is. If it's 0, it's going to be here. If it's 100%, it's this. And so we have a float number, we should use it. The timer percent is what I'm going to do. But I know this is going to be incorrect for some cases, and I'll get there in a minute. But this in-between position is now set to some position between these two. It's cool. We just need to use it. How would we use it? Well, it's a vector 3. We can actually just say set door positions to the in-between position. This will set the door positions. We tested that. I'm asserting this will be a percentage of time, and we could technically test that. We could just say print this timer percent, and that would print it out for us, and that's fine. But what I'm looking for is what this one does. So I'll separate it. This one, I want it to find the position to move the doors based on reset and activated, and then also this number. And so let's look at this number. Let's look at where these doors move. Let's see the doors move. That's what I'm saying. So it says reset, and I'm going to play, and I'm going to set it to be activated, and then I'm going to say test. So what happened? Well, it jumped open and then closed. And then at the end of that timer, it reopened. I'll set the change time to be 2 seconds long to really show what's happening. I'll set it back to reset, and wow, that looks perfect. It actually does look good. But activated does not. Check it out. Oh, it jumped back out, and it looks like it's closing again. But then at the end, it opens. What's going on? Well, it's doing what we told it to do, first of all. At the end of going toward reset, it sets that position to the reset. In other words, close. That's exactly right. At the end of activated, it goes to the activated position, which is open, boom, which is correct. And in between, it's just running a timer down and going between two positions. The key is the timer's running down. That's all. The percentage, in fact, we can see the percentage here. Let me clear this. The percentage, oop, it's going from 1 down to 0. And it does that no matter which direction we're going. Yeah, from 1 down to 0, which means that lerp always looks like it's closing. So at the end, it looks right. The moving looks wrong. Unless we happen to be going toward reset. Reset looks fantastic. So what do we do? Well, we need to change it if we're actually going to activate it. How do we do that? Well, let's look. The target position is kind of what we need, right? Yeah. If the target position equals activated, right? I mean, because this is the case where things don't look good. This looks great. So this is great, except when, in other words, if target position equals activated position. If that's true, then what do we want to do? Well, this percentage is wrong. It is like going from 1 down to 0 when it should be going from 0 to 1. I mean, I guess we could also make a separate lerp with these two flipped and it would do the right thing. Should we just do that? Okay, let's just do that. I mean, what I was going to say was we can change the timer value it uses. This timer percent could be, I don't know, 1 minus timer percent, and it would do the same thing that we're about to do here, but this is fine. We'll do this. That's fine. We've already defined in-between position as a vector3 variable, so I'm not going to say what class it is again. This would be defining a new variable, and since we already have it, it would give us an error. Instead, I'm just going to say reset that variable to this instead. So we set it to something. I'm going to say, yeah, no. Reset it, because we're actually trying to get to the activated position. So all I did was duplicate this line and switch these two inputs. Lerp between activated and reset instead of lerp between reset and activated. That's all. Use the same percentage, and I'll bet that'll work fine, because we're just trying to flip it. Yeah? Let's test. Play. Hey, door, can you activate, please? Go. Oh, looks pretty. Hey, door, can you reset, please? Oh, it looks pretty. Can you see? Is my avatar in the way? I'm sorry. It's pretty. And could we make it go slow? We absolutely could. If we set our doors to be moving slowly or moving quick, right? We can totally do that. Yay! I'm going to stop right now, I promise. But that means activating doors is cool. Does it mean that we've solved the problem? What happens when the character's here and it's trying to close? No, that's another problem we're going to solve later, okay? But we move the doors. In fact, I don't need this debug. I don't need to make extra text in the log right now. So I'll clean that up. I will reactivate this because we said we would do that. And I will remove my test stuff because I don't need this anymore. It is tested, and until such time when it is not working, we will come back and fix. Otherwise, we're pretty sure it works. And we will come back and do something to check before we move, I guess. In fact, we might even do that. No, not on this signal. Oh, we have to figure it out. We have to think on it a bit. But right now, bro, doors. Do-do-do-do-do. Our friend says, I would love to get in the door. Can I get in the door, please? Let me get in the door. Oh, please, door. Door. Ah! And we say, oh, okay. Oh, we can't because we just deactivated the test. Darn it. Sorry, little guy. We need a button to open the door. Oh, that was not satisfying. But we did just do it. Did we not? We did. I'm sorry. I'm over. I'm going to stop. This is a cartoon ape that enjoys making games as well as playing games. Such a nerd, such a nerd, such a nerd. And so we do. But if you're watching me right now, bro, hate to say it, you're also kind of a nerd. It's okay. You're always welcome in a jungle, and when you do come by, please use Command Tie. Command Tie lets me know you're here, and until then, have fun, do well, be good, stay safe. See ya.